Okay, in this video we're discussing force and pressure, what each of them mean, and how you measure them. We're going to talk about velocity and acceleration, flow rate and how that's measured. Then we're going to talk a bit more specifically about how force and pressure affect water flow. In plumbing systems, water pressure and the different types of water pressure. So there's static pressure, dynamic pressure, how they're different from each other. And finally, things that affect or primarily slow down water flow in your pipes or your plumbing system. Okay, so question, what unit measures velocity? A, Newton, B, Pascal, C, meters per second, or D, meters squared? The correct answer is C, meters per second. That is the base unit, meters per second. So velocity is basically the speed at which something is moving. So it measures how fast, but also in which direction an object is moving. Okay. The other two answers, A and B, newtons and pascals, it's important to remember each of those and know that newtons measures force, while Pascal measures pressure. Easiest way to remember that is that Pascal, pressure, P. If you know that, then you can remember the other one. Force is Newton. Okay, question. What is acceleration due to gravity on Earth? A, 9.81 meters per second squared. B, 1 meter per second squared. C, 10 meters per second squared. Or D, 100 meters per second squared. The correct answer is A, 9.81. Just memorize that because it turns up in the exam often. And the reason why Earth is important is because this figure changes on other planets. So, for example, on the moon, it would be less than that. That's why there's less gravity on the moon. Okay, so this is an example of when the 9.81 might turn up. Okay, so they tell you a cistern contains 50 kilograms of water. This is the question, right? Then they want you to calculate the force due to gravity acting on the water. So in order to answer this, you're going to need to know the formula for force, right? So the questions ask us for the force. We need to know the formula. So 9.81 is important to remember because the formula for force is mass times gravity. So if a gravity is 9.81, we just need to know the mass, which is 50. So 50 times 9.81, it's going to be A, 490.5. Okay, so do remember this. It's one of the more important formulas you're going to have to remember, and it could come up. Question, how is flow rate measured? A, liters per second. B, kilograms per meter. C, newtons per second. Or D, meters per second. Correct answer is A, liters per second. Okay, so flow rate is just the amount or the volume of water flowing past the point. So usually in plumbing, we want to know the flow rate coming out of taps, right? So if the flow rate will be the number of liters coming out of your tap per second, right? And remember, 1 liter is just 1 kilogram in mass. Question. What unit is used to measure force? A, Pascal. B, Newton. C, meters per second. Or D, kilograms. The correct answer is B, newtons. So if you remember, I just said pressure is pascals, pp. That means force will be newtons. Okay, so 1 newton is the amount of force required to accelerate 1 kilogram at 1 meter per second squared. You probably don't need to know that. Just remember newtons is for measuring force. Okay, now pressure. Question, pressure. Pressure is defined as A, force times area. B, force divided by area. C, mass times gravity. Or D, velocity divided by time. The correct answer is B. B. Force divided by area. So let's explain that a little bit. Pressure equals force divided by area. It acts on, right? So that's newtons per meter squared, or a Pascal. Okay. So the larger the area reduces the pressure for the same force. So that a good way to understand this is, if you look at this picture, just imagine you're pushing down with your left hand and your right hand at the same time, and you're applying the same amount of force. You're pushing exactly the same on each hand. Which hand will hurt you more? It's going to be the one on the right. So just imagine this is a pin, right? And that's a brick. The brick is flat. So the force that you're applying with your hand is the same, right? But because the area of the brick is much larger than the area of the pin, right, that means there's going to be more pressure here, which you'll feel in the form of pain on your hand. So it's the force applied divided by area. Okay, question. What is 10 meters head of water equivalent to in pressure? A, 100 pascals. B, 100 kilopascals. C, 1 kilopascal. Or D, 10 kilopascals. Okay, the correct answer is B, 100 kilopascals. 100 kilopascals is equivalent to 1 bar of pressure. So the main thing you want to remember here is that every 10 meters of head, so head here just means height. It's a height between the water cistern, the place where you store the water, and the tap. So let's say you've got a tap on the ground floor and it's 10 meters up to the attic where the water is stored, then you'll have 1 bar of pressure, right? So the higher the difference, the higher the head, or the more the head, you'll get more bars of pressure, right? So 20 meters will be 2 bars, 30 meters, 3 bars, and so on and so forth. Okay, so pressure increases with water column height. Question. What happens to velocity and pressure when pipe size decreases? A. Velocity decreases but pressure increases. B. Velocity increases but pressure decreases. C. Both increase. Or D. Both decrease. Okay, so to explain, let's say you've got a 22 mil pipe and it moves down to a 15 mil pipe. What's going to happen to the velocity of that water running through the pipe and the pressure? The correct answer is B, right? The velocity will increase, so the speed of the water, it will get faster, right? However, the pressure will decrease. Okay, this is quite important, and it will be relevant to your job as you start working. So this is down to something called the Bernoulli effect, alright? So as the diameter gets smaller, even though the water's moving faster, that doesn't mean the pressure will increase. The pressure actually decreases. Okay, and the reason why this is important is because it's counterintuitive. You might think, well, the faster the water's flowing, the pressure should be higher. But in fact, no, that's not the case, right? So don't make the mistake of thinking if you've got low pressure upstairs and you've got a 22 mil run, if you just reduce it to 15 mils, you'll get better pressure. You won't. The pressure will actually decrease. Okay? And this is a picture. Just explain. So you've got, let's say this is 22 mil. And as the water goes down to a 15 mil smaller diameter, even though it's moving faster, the pressure coming out of here will be less than the pressure of the water here. Question. Which factor increases flow resistance the most? A. Larger pipe size. B. Shorter pipe length. C. Multiple pipe bends. Or D. Smoother pipe material. The correct answer is C. Multiple pipe bends. So the more bends you have in a run of pipe, every bend will cause more resistance, right? Because the water has to change direction. That causes turbulence, which will lead to more resistance, which will reduce your flow rate. So as a rule, you want to minimize, don't add any unnecessary bends into your pipe work. Okay, question. How does pipe length affect flow rate? A, it increases flow rate. B, there's no effect. C, it decreases flow rate due to friction. Or D, it makes the flow rate constant. The correct answer is C, right? So friction is basically two things rubbing up against each other. So in this case, it's the water rubbing up against the inside walls of the pipe, right? That happening alone, regardless of the length of the pipe, is causing friction. So the longer the pipe run, the more friction there's going to be. Okay, moving on. Which pipe material offers the least friction? A, LCS, low carbon steel. B, polybutylene. C, copper. Or D, PVC. The correct answer is B. It's actually polybutylene, okay, although we mainly use copper in pipes, in plumbing. But polybutylene is technically has the smoothest bore. So that means on the inside, it's smoothest. And the smoother the surface there is, the less friction there will be. Right, and the less friction will be, means there will be less resistance. That's basically what you want, because resistance will slow down the passage of water. Okay, and just fun fact, so LCS is rough, and that increases resistance. Okay, question, atmospheric pressure at sea level is A, 50 kilopascals, B, 101.325 kilopascals, C, 150 kilopascals, or D, 200 kilopascals. Correct answer is B, 101.325. Just remember that the same way you're going to remember that the acceleration due to gravity on Earth is 9.81. Try to remember this, because this will probably come up in the exam. 101.35 at sea level. Okay, why is that important? Because pressure decreases with altitude. So the higher you go up above sea level, let's say in the mountains, the less pressure there will be. Okay, and that's also why your ears pop when you go up and down in the aeroplane, because it's due to the difference in pressure between sea level and going high in the atmosphere. Okay, question, what happens to flow rate if pressure increases? A, flow rate decreases. B, flow rate increases. C, stays the same. Or D, stops. Correct answer is B, flow rate increases. Okay, so this is to be expected, is quite normal, so it's intuitive. The higher the water pressure, if you have high water pressure, you're going to have high flow rate, right? So let's say you turn on a tap in your house and there's hardly any water coming out, right? You'll say, oh no, the water pressure is low. And when the water pressure is low, that means you're going to have a low flow rate as well, right? So as pressure increases, flow rate also increases. Okay, yeah, so higher pressure pushes the water faster through the pipes. Okay, question, what does dynamic pressure refer to? A, pressure of water at rest. B, pressure of flowing water. C, atmospheric pressure. Or D, pressure of solids. The correct answer is B, pressure of flowing water. Okay, so the word dynamic, it just means moving. If something is dynamic, it's moving, right? So it's going to be the pressure of flowing water. Okay, so the opposite of dynamic pressure, or the other important pressure measurement, is that of static pressure. Static is the opposite of dynamic. So if dynamic means moving, static means staying still. Right, so static pressure is pressure of water at rest. So if we're talking about pressure in the pipes as the water's flowing, that's going to be dynamic pressure. If you're talking about water in the cistern, let's say, or the pipes when the tap is turned off and the water's not moving, that is static pressure. Okay, so let's recap. Velocity is the speed at which something is moving. Okay, what is also the speed and direction, and is measured in meters per second. I forgot to cover acceleration, just very briefly. the difference between velocity and acceleration. So velocity is the speed. Acceleration is the change of speed, the rate of change of speed. It's how quickly something is changing its speed, i.e. getting faster or slowing down. Okay, so force, we said, is measured in newtons, right? Force is what makes something move from A to B, okay? And remember, gravity on Earth is 9.81. Static pressure is the pressure of water when it's still, right? And we talk about that in terms of head. It's very common. So we talk about 1 or 10 meters of head. That means height, right? So for every 10 meters, it's 1 bar pressure. Okay. Opposite of static pressure is dynamic pressure. That's measuring the pressure when the water's moving. And then finally, flow rate depends on the pipe size, right? So the length of the pipe, the number of fittings or bends you've got in the pipe, and the pressure